Hi, welcome to today's DestinationLoRaWAN webcast. We are about to get started in just a moment. Gonna wait to give everybody a chance to join us. All right. You have joined the Selecting Complementary Technologies to Elevate Your LoRaWAN Solutions webcast. Welcome, and I'm Ashley Pope, both the host and a panelist for today's webcast. Before we get started, we have a few reminders on how to maximize your experience during the webcast today. Pushing F5 on your keyboard will refresh your screen if you see that your video or audio is behind or off, so don't panic. There's also a toolbar at the bottom of your screen, and pressing the help box will direct you to how to solve technical issues you may be experiencing during the podcast. Another important box is the Q&A box, where you can submit your questions throughout the webcast and have a group of experts online to answer your questions throughout the webcast. Don't wait until the end to ask your questions, as we do not have enough time today to allow for the panelists answering questions at the end of the webinar. Lastly, you will see the webcast resource list, a link to today's slides, along with some additional relevant materials. All right, so I'm going to introduce our sponsor for this session. Oxit is proud to be sponsoring this session on Selecting Complementary Technologies. Oxit is a IoT engineering services company with 10 years of IoT experience, 8 years specific experience in LoRaWAN, lots and millions of devices and solutions deployed. And yeah, so we are the sponsor for today. Happy to be sponsoring. Another thank you to the DestinationLoRaWAN series sponsors who help make these webcasts possible. Thank you to MachineQ, a Comcast company, as the DestinationLoRaWAN Gold sponsor. And thank you to our two silver sponsors, Birds and Charter Communications. All right, now to get to today's topic. This webinar is focused on multi-protocol connectivity and some of the complementary technologies that work alongside LoRaWAN. I'll be starting with an overview about LoRaWAN working alongside other IoT technologies. Then our 5 panelists will each take a deeper dive into one set of complementary technologies. So let's get started. So introducing the topic of multi-protocol solutions and complementary technologies, we start with LoRaWAN being this powerful technology that offers us the freedom to innovate and differentiate how it's used by not defining the type of deployment in the standard. It has the capability of elevating and improving your IoT solutions by working alongside an existing protocol that's already implemented by your solution. Your customers' data needs, this says may transform, but they will inevitably transform over time. The goals originally identified in a solution will inevitably change and adapt as your client grows and their product grows. With LoRaWAN, you can optimize that device or solution by expanding the possibilities for data collection. So just briefly to introduce this topic, I want to touch on why you would combine technology. There's 3 key points that we discuss all the time with clients in approaching the thought of multi-protocol or utilizing and leveraging complementary technologies. One being design diversity. This goes back to the point that I kind of just touched on in that introduction, in that by creating a product that has hardware diversity within it, future-proofing with protocols that you might not have a clear use case for today, but that you're unclear if your product or your customer's use case will grow as time goes on. It's incredibly valuable for your solution. Being diverse in your design gives you the freedom to make changes as your solution and deployment go forward. This can inevitably translate into cost benefits and some other things we'll get into in the next slide. The second point of that being increased ROI, which is that the concept that your client's use case changes and your initial entry into that use case being, say, an outdoor application, by utilizing complementary technologies and combining technologies together, you can increase your ROI by expanding from your original targeted use case, right? So if you were an outdoor solution focused, then if you have the future-proofed multi-protocol or the additional technologies in your hardware, you can actually expand that ROI and now work on, be useful in an indoor application as well. The third point of this is diversity of environment. And it's really interesting because inevitably the environment that your product is initially deployed in will not be the environment that your client deploys all your products or solutions into. They may start with a environment that is very focused on, range being the issue. But then as time goes forward, penetration becomes a problem, permutation of obstacles, as well as battery consumption. There may be limitations on gateways. There may be limited access to power. So if you have this diversity of environment aspect through leveraging multi-protocol and having complementary technologies combined, you're future-proofing yourself in that diversity of environment aspect. So you're not limiting yourself to one specific environment where your solution and your product work. So just to kind of give you an intro on that, we'll move into the next one. And this is an interesting part of the question of complementary technologies. We often find that there is a misconception with LoRaWAN that it is a replacement. And companies look at it and they are being asked to replace their existing connectivity, which to that company would mean a lot of migration costs, a hardware redesign, firmware changes, and those are all costly things to take on. The truth is that LoRaWAN can enhance and improve solutions alongside other technologies, and it's an optimization tool that will enhance solutions. LoRaWAN's perfectly capable of standing on its own, but it works very well in a partnering capacity. So looking at the value that LoRaWAN provides in partnership, there is the lowered operational cost. So when you integrate LoRaWAN into your solution and into your product, you are opening the door to lowering your operational costs, one, by reducing the amount of hardware that you have in the field, which means lowered maintenance. It means, lower hardware costs per solution, period. And it also means that you have less of that burden there for maintenance as time goes on, because inevitably when you have a lot of hardware out in the field, you have to maintain that hardware and you have to send out maintenance as well. So that's just one area that LoRaWAN can lower the operational costs. The second part of that is power reduction, which is longer device life. Power reduction in LoRaWAN it's an incredible offering that it gives solutions where your battery consumption can be incredibly low through data transmissions versus using cellular or other protocols that kind of eat up that battery very quickly. So that's a way that it can really provide value in partnership to another protocol that it takes more of the battery in its transmissions. The third item is in range extension. So where you are deployed a solution and range becomes a factor for you. And you need to extend your range, but you still need the support of your other protocols. By integrating LoRaWAN, you're actually allowing for range extension while still leveraging the capabilities of your other protocols as well. And then from a configuration standpoint, this is a very interesting one as well. LoRaWAN has a simplicity and ease of use once deployed in a solution. So for your field agents or your field engineers or your field operators who are going out and interacting with the technology, LoRaWAN can be paired with another type of protocol that's more difficult for the field operator to navigate and provide that simplicity and ease of use from a configuration standpoint. This is an area where it pairs very well with Bluetooth, which is also very easy to configure. And then just the third part of this is getting into this session for complementary technologies. Member companies today are going to discuss why they're using complementary technologies with LoRaWAN and how those complementary technologies have unique benefits to a LoRaWAN solution with what is already implemented. So some examples of what's going to be covered today is Bluetooth, Wi-Fi, RFID, Scada, and broadband. We're going to cover those in here as well. All right, well, that is it for my session in introducing the why would you combine technologies and why is LoRaWAN complementary. We're going to move next into, yep, go ahead, Gaurav. We're going to move next into your session. Take it away.
Absolutely. So, Gaurav Naik, I'm the head of engineering for MachineQ, a Comcast company. I'm also a member of the board of directors of the LoRa Alliance. So when it comes to selecting a IoT technology or wireless technology for your IoT solution, there's no one size fits all. There's a lot of trade-offs to be made between things like battery life, power consumption, RF performance, and bandwidth and range. So if you think about battery life and power consumption for your solution, one of the most important costs that you have to consider is the total cost of the device, the total cost of ownership over how long that solution is deployed. In some cases, it costs more money to replace a battery than it does to actually just replace the entire device. In addition, you have to consider RF performance. Where is your solution operating in? Is it in an area with a harsh RF environment, in an area which is an area where LoRaWAN really performs well when there's a high number of interferers? Or is it in an area that has a very robust and busy Wi-Fi network where something like Bluetooth or other Wi-Fi technology will not do well? And finally, when we talk about bandwidth and range, there's always a trade-off to be made between long range and throughput and short range and higher throughput. And so if you have a temperature sensor that's, say, transmitting temperature data once an hour versus you have an application where you need to transmit, let's say, images from a security camera, you have to consider all of these trade-offs before you decide on what technology to use. And in some cases, one technology is not going to work for your solution, so you have to combine two. And so LoRaWAN is very well suited for low power, long range connectivity. Today it's used ubiquitously for smart metering, smart city applications, industrial or facility monitoring, and also for asset tracking over long geographical areas. Bluetooth, on the other hand, is capable of sending short amounts of data continuously over a smaller distance. It is very ubiquitous in wearables for things like Bluetooth headsets, for your watches, but also, of course, it's on every single mobile phone. And as a result, if you combine these two technologies, you can realize the synergy of having Bluetooth on a cell phone or a mobile phone and the capability that provides. And so think of an installer who's installing your solution. Bluetooth on their phone gives them the capability of configuring or commissioning your LoRaWAN sensor, changing things like reporting intervals for, let's say, a temperature device or adjusting thresholds for a meter. And in some cases, you can configure those things over LoRaWAN using a downlink, but sometimes it's easier to do this in the field when you install your application. In addition, Bluetooth on your phone will make it very easy to do a firmware update over the air of your LoRaWAN device. You can also, of course, do a LoRaWAN firmware update over the air, which is standardized by the LoRa Alliance, but that's very well suited for devices that are already deployed. But when you're deploying the device for the first time, using Bluetooth is a great use case for it. And then, of course, for things like diagnostics, why isn't my device connecting to the network, or managing keys if you need to maintain your keys in the field. But finally, one of the really unique capabilities about Bluetooth is its capability to what's called advertise or beacon. And you can use that advertising or beaconing information to enable an asset tracking use case. And so when we talk about asset tracking, we sort of look at the entire sort of what's out there with asset tracking, what LoRaWAN is capable of when it comes to asset tracking, but also what other technologies are out there. And there's a lot of trade-offs to be made here between power consumption, between the accuracy, and whether any of these technologies can be used indoor or outdoor. And as a result, at MachineQ, we have taken two of these technologies to provide a full stack, fully shrink-wrapped solution to the marketplace that enables the type of accuracy that customers are looking for. So MachineQ for asset tracking is an end-to-end asset management solution. It has Bluetooth tags that get attached to assets, devices that we call bridges or edge locators that are Bluetooth LoRaWAN devices. And these are placed indoors in the areas that you want to track your assets in. And of course, the Area 8C with the MachineQ 8-channel LoRaWAN indoor gateway that includes Ethernet and cellular connectivity. That all comes along with a SaaS-based application. And so as a result, combining Bluetooth and LoRaWAN, we can enable up to 3-meter indoor asset location accuracy. We can provide 10-minute update frequencies and a tremendous and superior battery life of up to 10 years. and we can support thousands of assets in a single location. And on top of this platform, we have the MQ Locate SAS application that lets you view your assets, manage your floor plans by uploading CAD files, asset tag management and activation, bridge activation and management, the ability to create alerts on your assets if your assets move or if they leave a certain area, things like indoor geofencing, the ability to activate an LED on the tag. So we call this the sort of last mile location. So if you're out looking for your asset and you come across a room where your asset might be in, through the mobile application, you can enable the LED on the tag itself, so it'll blink. And finally, you don't have to use our application. We have a lot of customers using our APIs to integrate our location data into their existing ERP system, whether they're using SAP or some other thing for managing their enterprise assets. And so overall, this solution of combining Bluetooth and LoRaWAN provides sub-room level accuracy, 3 meters or less, and so you can find your assets with confidence, a superior 10-year battery life for your tags. And like I said, the total cost of ownership is really important to think about what it would cost to change batteries in an asset tag if you're tracking tens of thousands of assets. It doesn't make any sense, and that's why we have optimized our solution to get you the longest battery life available in the market. And finally, this LoRaWAN-based solution is independent of your Wi-Fi network. It's independent of your existing IP-based network. As a result, it provides isolation, provides superior security that you get with LoRaWAN without having it touch your corporate network. And then finally, this solution is delivered end-to-end by MachineQ, so hardware, software, installation, and ongoing maintenance, including project management, to get this installed into your facility. But on top of this, you get the MachineQ LoRaWAN connectivity platform. So you can add additional use cases. So asset management is your first use case, but if you have other LoRaWAN use cases that you want to deploy that are things like facility monitoring or energy management, you get that network, the ability to deploy those use cases as needed. And then finally, as I said, this gets you the lowest total cost of ownership, lower than RFID and other asset tracking technologies, while maximizing the efficiency that you get by the solution. And so I want to make sure that I leave some time for any questions. If there are any questions from the audience, Ashley, I appreciate that.
Yeah, sure. Thanks, Gaurav, for that excellent presentation on Bluetooth and LoRaWAN together. Looks like we do have an audience question that's come in, and I want to go ahead and address that with you. So while BLE and LoRaWAN are complementary, they are also different technologies. Can you talk about some of the challenges of combining the two?
Absolutely. That's a great question. So, if you think about, Bluetooth, it makes the assumption of a certain amount of bandwidth that you have available versus LoRaWAN, which has a much lower bandwidth because it's designed for a longer range. And so you can't just sort of take these two technologies and bridge them together, right? It won't work because Bluetooth is going to use a lot more bandwidth than your LoRa network is capable of. And so you have to take a look at each technology separately, figure out what you need from that technology, what capabilities you're looking for, select those capabilities, and then figure out how to filter for them. And that's what we do in our solution, that we really thought through how does this scale as our enterprise customers look at tracking tens of thousands of assets across their organizations. And so you think about Bluetooth, you have to configure Bluetooth correctly to make sure that it's using the least amount of bandwidth possible. And then you have to optimize the deployment of your LoRa network to make sure you maximize the amount of bandwidth you have. Thanks.
Thanks so much, Gaurav. Thank you for that excellent answer. All right, that's going to wrap up our recap on the Bluetooth session. Now move next into LoRaWAN and LTE with Hassam. Hassam, take it away for us.
Thank you, Ashley. This is Hassam Himimi, Senior Director, Wireless R&D, focusing on the enterprise private wireless networks and IoT smart cities with Charter. Today, we are going to talk about the complementary technology of the broadband to the LoRaWAN. And, the smart cities, as we know, is gaining a lot of attention because of the potential to enhance lives and as well as provide efficiencies. Rural America is not an exception for that, and we have a very good opportunity to work with one of the farms here, local farms in Colorado, where we are going to help them to benefit from the IoT using the LoRaWAN connectivity complemented with the broadband technologies, specifically the LTE. We have multiple other technologies, but we will be focusing today on the LTE that is also the 5G, for the future. So when we looked and we had the discussion with the local farm there, the main problem that they were facing is, number one is their operation is very paper and pen heavily, manual, and they are using a lot of personnel over there to manage the operation over there. Of course, they have some limited connectivity to the internet, which does not help them a lot. So the two big problems that we have is, number one, enhance their broadband connectivity to the cloud, and also start to take them from a manual paper and pen operations into a digital operations where they can do a lot of remote monitoring and enhance the operation and provide also insights into their operations. The connecting technologies that we are working with here are, of course, the LoRaWAN, where we are connecting up multiple sensors there. Also, the LTE, we started with the LTE, and we have the plan for the second phase is to move it into the 5G at the CBRS. Also, we have some Wi-Fi connectivity so that we can connect multiple of barns over there. Not only the connectivity technologies, but also we are relying and exploring with them other application technologies like the video surveillance, video analytics to help them to enhance their operations. And one of the things also that we are working with them is the license plate recognition for added securities for the guests and workers that they come into the farm. The farm challenge is, it is big area, 120 acres with a very sparse locations across this 120 acres. They have 55 horses with 3 barns and 4 pastures, with some outdoor training arenas as well as an indoor training arena. They have a farm gate that it's operating manually today. And of course, when the people they come, they don't know who's coming and who's leaving without having a signature on the entry book. So all of this, they wanted to see how we can help them to make it digital operationally and make it very efficient usage there. So the use cases, when we started to select the use cases, so we'll split it between the 2 major technologies. Of course, the LoRaWAN, where they needed to have the door sensors to make sure that the doors are open and closed, especially in the horse stalls. We have also some of the temperature and humidity sensors, and it's very, very important for them. You got to know from the owners that once they get to know the temperature, it helps them to make sure that the horses are, whether they are ready for the training or not. This is very, very important. Proximity sensors are also needed because they want to detect where the horses are escaping from the training area to the resting area. These are open areas there. And some of the horses, they just tend to move along, and they want to make sure that they are there. One of the things that we are exploring with them is also something very similar to what Gaurav was mentioning, which is an asset tracking. They want to know where the horses are, but in this case, we are not going to use the BLE, but we are going to use a GPS-based technology that is connected later on to the Bluetooth for transmission. Also, the proximity sensor starts to help them to detect during the rest hours, during the night, some of the abnormal behavior of the horses, which can be caused by some stress or something there. So this is also something very important. Of course, this will be complemented with some of the video cameras that we are putting there. Water consumption is another important thing. One of the things that determine the health of the horses is the amount of water that they are consuming. That's number one. Number two is it also makes the owners to monitor the water in the stalls for the horses and make sure to proactively go and fill the water instead of just waiting until the last minute or after that it is empty. Now, when it comes to the broadband, which is we are using here the LTE, there are also other use cases that the LoRaWAN could not fulfill. For example, enhancing the rural internet connectivity to the farm through a fixed wireless access, because the farm owners, they want to have a local surveillance cameras, and their current internet connectivity is not capable of having this, as well as, of course, connecting to the cloud so that they can do a remote monitoring, especially if they are on vacation or something. So a backhaul to start with is very, very important. This backhaul also, we are using it to provide the connectivity to the network server, which is a cloud-based network server of the LoRaWAN. The gateways, of course, we're using one outdoor gateway over there that will be capable of doing this. Also, we need to have a broadband connectivity to the different barns that are there. They have 3 barns over there and some of the clusters. We are also need to connect some of the backhaul, the connectivity of the surveillance cameras and the license plate recognition. So all of this are provided with the LTE and some other broadband connectivity. Another important thing is also in some of the barns, they need to provide a Wi-Fi connectivity to both the trainers and also some of the guests that they come there, the trainees. So they will allow them to have the Wi-Fi connectivity. The cellular connectivity there is also, not to the bar where they are providing extra services to their customers, to their guests over there, to provide a broadband connectivity to their devices. In conclusion and in a summary here, the complementing technology that we have selected here is the broadband, and we selected the LTE for the first phase at the CPRS, and then the second phase we are going to upgrade it to a 5G. And why we are using this complementing technology? Because the LoRaWAN will not be able to fulfill all the use cases and requirements that the customer is asking for. And this requirements requires both the narrow band, which is fulfilled by the LoRaWAN, as well as a broadband connectivity, which is LTE. The different use cases that we used are LoRaWAN, proximity, environmental, water consumption, and for the LTE, all the connectivity, the broadband connectivity surveillance cameras. And the business value here is allowing the rural America farmers to be smart and be efficient in their operations. Now, this concludes my discussion here. I'm open to have any questions from the audience.
All right, thanks, Hassam. Thank you for that excellent presentation. I think there's a lot of viewers who'll be interested to see this agriculture use case of LoRaWAN and LTE together. So thank you for that. Looking at our questions, it looks like one of our subject matter experts has flagged a question for you. So I'm going to go ahead and shoot that at you and get an answer. Right. The farm that you mentioned, it's large in size, and there are different facilities spaced out. How are you providing the connectivity to, for example, the stall, the indoor training area, and at the gate?
Yeah, so the LTE is the main backhaul that is coming there, but we looked into, can we use the LTE to provide the point to multi-point connectivity this could be a solution, but it will be a little bit more of an expensive solution. So one of the things that we used here is we used another broadband technology. We used multiple broadband technologies, including the Wi-Fi, of course, but another one that provides a mesh connectivity between the main building and the rest of those buildings. And this is proprietary at a 5 gigahertz, and it's providing good connectivity close to 100 megabits per second for each one of those links. Very good question.
Thank you. This is an excellent example use case of LTE combined with LoRaWAN. So thank you, Hussam. All right, we're going to move into our next presenter, who is Lucas with Weeby, and this is LoRaWAN and Scada. Take it away, Lucas.
Thank you, Ashley. It is very exciting to be here and share our vision on how LoRaWAN is complementary with different technologies, in this case, particularly in Scada. I'm the CEO and co-founder at Weeby. What we do at Weeby is a no-code end-to-end tool set to accelerate the deployment and the development of IoT and AI and computer vision technologies and solutions for industrial, manufacturing, agriculture, and supply chain. In this particular case, I will share our vision on the complementary with the Scada technologies. What is Scada, first of all? Scada means a supervisory control and data acquisition. That comprises a combination between computers, data networking, and also graphical user interfaces, with the goal to do supervisions for machines and processes in industrial networks. The main purpose of Scada implementation is to get data in real time and track and then monitor and control those industrial equipment and processes for different industries such as farming, manufacturing, oil and gas, minery, and smart cities. You may find Scada in many industrial deployments and different things. And you may think, what are the components, the main components on Scada? So you talk about HMI, that means a human-machine interface, and also remote terminal units that are the controls units that are connected to machines, and also you will find programmable logic controllers. That is that orchestrate an automation network. All of those are connected with different communication interfaces that in the wired or wireless technologies. In the wired, you will find many applications, and the most common use cases are in the 420 million pairs or serial or Ethernet. And then in the wireless, you will find a BLE, Wi-Fi, LoRaWAN, and now it's growing more the narrowband IoT and LTE as well. But all of that are signals that are wireless or wired and goes with different industrial protocols. So you may find as a Modbus and RS-485 under TCP, like the most common use cases, but also OPC, UA, and binary signals. So all of that, many legacy machines or many fully automated plants are getting that data to supervisory systems that are computer-based with softwares that also do the data processing and storage. When we go to the Scada Evolution, we talk about, like many years ago, about the first generation, that is a monolithic Scada, that is a master and slaves that are really locked in on that architecture. Then it jumped out to the distributed Scada, that is in a local area network. And then it evolves to networked Scada. So how to connect different locations in a wide area networks with different technologies. Today, what we are seeing is the fourth generation in this Industry 4.0 revolution. That is the Internet of Things technology plus Scada networks. You will find that many factories or industries already have a fully Scada networks that are already connected and in place. As we see at Weeby, is the next generation of these Scada systems and technologies, combining a no-code toolset plus artificial intelligence plus Internet of Things. That means that you will start in an easy way, getting connected things that before this technology, like wireless technologies, like LoRaWAN or BLE or Wi-Fi, it couldn't be possible. And then combining the edge computing with cloud computing. One of the great big challenges is that when you have HMIs that are TVs or different screens on the plant, you need to have a person that is walking around. But then today, with the portable HMIs, such as tablets and smartphones, and the easy way to generate the user interfaces with no code for the users is really accelerate the deployment and the access to the insights. What are the most frequent use cases for Scada? You will see power systems on the energy monitoring and control, and manufacturing industries, and also wastewater and treatment and distribution plants. Also, you will see in the food processing and agriculture that many things that are like a more Scada traditional, you will see that are trying to connect to the cloud. What are the benefits on combining the LoRaWAN with no code and with the Scada system? That you will get a 40% faster development and deployment on the different solutions to really have a rapid ROI. And then it's a 35% on the improvement in alarm resolution. Combining the AI and natural language programming, it will be really faster and 80% less time to find the insights instead of an HMI and having the knowledge to explore those more rigid Scada networks. So by asking natural language and the user persona, the frontline worker can access the insights instead of needed technical skills to go through, find that in the real time. Speaking about the power systems in energy monitoring and control, if you think in manufacturing, you have like three different levels of energy. At the utility level is providing the main energy for the main panels and sub-panels. And in that, you just have the energy and you need to have something like this Schneider Electric or Siemens power meters that are installed in the sub-panels. And then you don't have visibility on what happened there. You need to send a person to see what is happening there and don't have access on the historical data. Our use case, what we did on different customers, is connecting an industrial transceiver. In this case, we used one of the LoRa members, Tectelic transceivers, just connected really easy with two cables to the power meter on the Modbus RS485 and start extracting in real time energy, quality, harmonics, and then the FICOSEN and different peaks on the quality and the energy. So at that level, we can understand also the quality of the energy, prevent and do anomaly detection through real-time alerts, but also focus on the impact on the sustainability. So because the energy has a multiplier on different countries, different regions that affects on and represent the carbon footprint. So that was really easy to connect and then accessing that historical consumption data. And going to the other layers on the energy consumption is going through a contextual on the production processes, but also going a third level down is monitoring the machines and combining with not only energy consumption, but also with other LoRaWAN sensors, that is vibration and temperature sensors. So for that, we can understand how is the machine and the process around a production line is performing by doing a monitoring on energy consumption plus the vibration and the temperature, and then we can detect with an AI algorithms, artificial intelligence anomaly detection to improve the maintenance task and also to predict and do prescriptive maintenance for those machines. In a nutshell, having the Scada implementations helps organize the real-time data, track and monitor and control the industrial equipment and processes, and combine it with the different technologies like LoRaWAN, BLE, and narrowband IoT and Wi-Fi allows to really get that contextual information and transform the factories or the industrial operations and supply chain. No, with just the automation team that is connected PLCs or that specifically technology. I would like to open a couple of seconds for questions to the audience. Thank you very much.
Sure. Yeah, thanks, Lucas. Thank you for that excellent presentation on Scada. I know that many times when I have visited oil and gas and power trade shows, there's a lot of questions as to how LoRaWAN and Scada can work together. So this is a great presentation you've put together. Looks like we have a question flagged for you by one of the subject matter experts that came in from the audience. So let's go with this one. How long does it take to connect a legacy machine to a Scada system with LoRaWAN? And this is a two-part question, it seems. Is the information collected by LoRaWAN accessible in local historians and OPC-UA servers?
Oh, that's a great question. So one of the beauty of LoRaWAN is that the long range, low power consumption, and in some cases, you don't need even battery power to do energy consumption. So this is very easy to set up and deploy. Like in the case of the temperature and vibration sensor, it's just a sensor that you stick and play to the machine. We call stick and place because you don't need to power, and then you start gathering the vibration in real time. And for the case of the energy consumption as well, you just put the clamps on the wires and then start monitoring the energy consumption. So that is really easy, don't need technical skills, and it takes minutes on just putting the device. And then since it's a long range and the technology that LoRaWAN is can get that data real easy. For the second question about the historians and the UPC UA, that's a really interesting, because many factories want to keep the information to get the data locally to make the decisions and control on the automation. So this, the LoRaWAN technology with a local LoRa network server can push the data locally to the historians and the UPC UA servers locally in the LAN, or also pushing to the cloud. So it's a very flexible technology that can be combined in a hybrid cloud computing and edge computing architecture. Yeah.
Thanks so much, Lucas. And audience members, please keep in mind you can follow up with questions during these live sessions. And if you aren't getting your questions answered, please reach out and get someone to answer those for you later on down the road. So thank you, Lucas. Thanks for the catch up on LoRaWAN and Scada. We're going to move to our next session, and I believe our final presenter, which is LoRaWAN and Wi-Fi. Rohit, take it away.
Hi, everyone. Good morning or good afternoon, depending on where you're based. My name is Rohit, and I work as a product manager for geolocation and Actility. And today I want to talk about how LoRaWAN and indoor Wi-Fi positioning are complementary to each other, especially for industrial IoT use cases, which demand seamless indoor-outdoor positioning with very high accuracy and long battery lifetime. And the main reason Wi-Fi is great for tracking, and a lot of our customers use it, because there are already existing installations that you can easily leverage for tracking without deploying any additional infrastructure. And the primary applications that we see around industrial IoT are around asset tracking, which are critical parts of customer operations, and the major problems that the customers are addressing with these use cases around asset theft, asset utilization, inventory management, and so on and so forth. And some of these use cases can actually demand accuracy of up to 1 meter with a very long battery lifetime of the trackers. So in the next few slides, I will show you how the overall solution works. Okay, so here's the architecture for the overall solution. So the ABIWay trackers are basically scanning the Wi-Fi access points, BSS IDs, when they're inside the building, and when they're outside, they're doing GPS or low power GPS, depending on the configuration of the trackers. And this is finally sent to the LoRaWAN infrastructure, followed by ping-pong location, which basically is filtering and processing the GPS information. And then this information is fed to the HERE tracking platform, which basically does indoor high resolution tracking, which means you can track up to 2 meters depending on the density of Wi-Fi infrastructure in the building. And the HERE tracking platform also has a radio mapping infrastructure, which allows you to map the indoor Wi-Fi infrastructure with the indoor maps of the building. So the key benefits of this solution are to have a seamless outdoor-indoor tracking. So when you're outside, you can use GPS or LP GPS for very high accuracy and very low power. And when you're inside the building, you can leverage this HERE tracking solution with the Wi-Fi fingerprinting to get less than 5 meter accuracy. There's no dedicated infrastructure required. As I said before, the devices are low power that can last for weeks and months, depending on the battery size and the configuration of the devices. We have this solution deployed also for human tracking and also for asset tracking. So there are different types of trackers that are aimed at different use cases. And then finally, the key use cases that you can address this are around people safety, warehouse management, goods tracking, and so on and so forth. So finally, to summarize the solution I talked about, so we believe that LoRaWAN and Wi-Fi work very seamlessly together without the need for deploying additional infrastructure to achieve the geolocation of 2 to 5 meters, which is a very high precision. And the way it's working is that the WWA trackers are basically scanning the Wi-Fi access points when they're inside the building, and when they're outside the building, they're relying on GPS. And combining ThinkPark location, which is a WWA backend and HERE tracking platform, you can achieve very high accuracy for both indoor and outdoor. Thank you.
Thanks so much, Rohit, for covering that session on LoRaWAN and Wi-Fi. I know personally in what Oxid encounters, LoRaWAN and Wi-Fi go together hand in hand and quite frequently. So let me check and see. I believe we have a question for you also. All right, yes. Okay, so Rohit, how does your solution compare to the regular Wi-Fi indoor geolocation that's offered by Google? Can you give us an answer to that?
Yeah, so basically when you have a phone and you're inside the building, the way your phone is showing the position, because Google Maps is basically aggregating information from Wi-Fi infrastructure that is inside the building, your cellular network, and the GPS. So if you're inside the building, most likely GPS is not working. So usually you can scan up to 3 or 4 access points or even more. And you can only say that I'm inside the building, but you cannot know where exactly and in which room you're in the building, on which floor you are inside the building. So the solution that is offered by Google only works when you have an infrastructure that is public, which means that if a very remote Wi-Fi infrastructure on a seashore or a very remote location, most likely there are not many phones around that location, so the Google or even HERE Wi-Fi geolocation will not result in any location, or it will be a very bad accuracy. And the second is that solution is not precise enough to give you 2 to 5 meter accuracy, which is what these applications are asking for. That's why that solution does not work very well for these use cases.
Thanks, Rohit. That's a great answer. And thanks once more for taking us through LoRaWAN plus Wi-Fi for that. I also wanted to draw attention for the audience and those watching the podcast session. At the end of each of these presentations, you'll note a slide that recaps the how, the why, and the value of each complementary technology, and you'll be able to access that at the end of the session as well. So great material for those of us who are trying to spread the word on LoRaWAN's capabilities and complementary technology capacities. All right, looks like we were able to get our final speaker to join with us that we weren't sure if it was going to make it. So next up, we're going to have the LoRaWAN and RFID session brought to us by Kush. Kush, take it away.
Yep. Thanks, Ashley, for the introduction. So my name is Kush Mishra. I'm the CTO and COO of Senra. We are a network operator based out of India, and we also provide end-to-end services like analytics, hardware. I'm going to be briefly talking about LoRaWAN plus RFID as a complementary technology and few of the use cases that we have implemented in the past and what value additions that we see. from both the technologies combined. So jumping into the RFID technology, to start and give you a brief overview of what the technology is all about. RFID is primarily used to detect, to read information from RFID tags. And there are a few prime advantages of doing that. Basically, there's no line of sight required between the tag and the scanner. So it's not like a barcode or QR code in that sense. You could have a high throughput, as in you could have multiple RFID tags passing in front of the reader. There are different kinds of tags, passive, active, and depending on the technology, different costs associated with both. It also comes in different shapes and sizes, but it does ensure reliable data capture. And it has seen a very wide adoption across the globe. A lot of different kind of solutions, especially for logistics, are very popular on RFID using the tags. It also offers the customer real-time process automation in terms of automatically capturing the tag information without any sort of human intervention. So these are some of the highlights of the RFID technology. Quickly also talking about LoRaWAN, I've just added a small representation of what the topology looks like. But basically, the LoRaWAN technology offers low power consumption on the end devices, very long range, one of the best in the industry. It's got the highest, or one of the highest link budgets in the industry. So out of all the out of all the RF technologies, LoRaWAN offers a very high penetration through dense materials such as concrete, metal, etc., and very high resistance to interference. It also helps lower down the total cost of ownership. Because of the high range, you are able to deploy less number of base stations to cover a very wide area. And the most important thing, I mean, the entire data is secured. It's AES-128 encrypted by the protocol, both at network and application layer. So coming to the technology integration side, I've just added a small block diagram here to show what it looks like. The first component consists of a RFID scanner, of course, which consists of an antenna and the reader itself. The scanner has very common communication ports such as RS-232, RS-485, or RJ45. We use the RS-232 port of the RFID scanner to collect data from the scans and transmit that data using our partner device to transmit it over a very long distances on LoRaWAN. From there, the Senra network server kicks in, where the backhaul from the LoRaWAN gateway comes to the LoRaWAN network server, and we can show the data on an IoT platform called Ginger, which is also something Senra offers. This is what a simple setup looks like. It's our lab setup. This is what the end-to-end integration looks like. You can see the antenna, the reader, the device, and the gateway. A snapshot from our network portal, what the data capture on the network server looks like. You can see quite high RSSI and SNR values, and basically a lot of uplinks which signify the tag that are swiped onto the RFID reader. We have a unique capability to display this tag information as per their payloads on the IoT Analytics platform called Ginger. So the payloads that you see in the center are actually the tag informations, the tag payloads that are identified from the RFID reader. And we are able to achieve a packet success rate of almost near to 100% due to our firmware that we write on these RFID readers. I'll just discuss briefly about a very unique use case that we are currently working on. The use case is for the Indian Railways for their wagon tracking and management application. What we do is so the Railways has a large problem of being not able to identify in real time where their coaches are, where their wagons are, and how they're moving through the Indian railway network, which is one of the world's largest railway network. It's quite difficult to manage. The Railways RFID department called Chris has been working with us to kind of integrate their RFID tags on these wagons, and they generally deploy these wagons 4 or 5 kilometers or 10 kilometers from the nearest station. So it's quite a difficult, challenging task to kind of take the readings from the RFID reader 5 kilometers away from the railway station, put a cable from the RFID reader all the way to the central station, have men and servers located at the station to monitor these RFID tags and those sort of things, and that becomes quite challenging to collect data. It's a very capex heavy kind of a model. What we do is we have small RFID tags installed on these the railway wagons. I've just added a small animation here to show you what that looks like. And then there are RFID tags which are deployed like 5 kilometers away from the railway station. The tags automatically scan whenever the train's passing in front of the readers. The tags are already identified. And from there, we capture this from the RFID setup to our LoRaWAN device. The transceiver connects to the RS-232 port behind this RFID reader and transmits the signal over to the nearest LoRaWAN base station, which is generally located on the railway station, the nearest railway station, which is still, I think, about 5 to 6 kilometers away. So this enables the tracking, but it also drastically reduces the cost of laying the underground cables from the reader to the station. It also drastically reduces the need for people, the need for software servers that are supposed to be set up near these railway stations. So all in all, the solution is reducing the total cost of ownership. In this slide, I've quickly just shown you that RFID has a very wide adoption. We use this for one specific use case, but in general, we have done past deployments where we've used this for logistics management. And it can be used to quickly read the data, to identify individual equipment, machinery, men, or vehicles. And the problem with RFID is just that, it lacks long-range communication. I mean, it offers you ports and communication protocols, but to be able to actually lay down those optic cables or RS-232 cables over distances and having local servers, that's really painstaking. And where LoRaWAN enters this game is the long-range communication, and apart from power efficiency, it can offer the backhaul very reliably. So the integration opens up a lot of use cases where the stakeholders could, capture value from both the domains of different technologies. So yeah, this is in a nutshell what we have done. The complementary technologies basically cover passive, short range, and very low cost data capture of the RFID, and then combine it with the long range backhaul that LoRaWAN offers. The simple method they work together is using the RS-232 port in our case, but this could be taken to different kinds of COM ports, which doesn't matter as long as you're capturing the tag information from the RFID readers. Senra's LoRaWAN network server receives this data and forwards it to our application platform called Ginger, and thus we can give an end-to-end offering from not just the hardware network, but also the end application that we offer. And the real value add is the massive reduction in both the capex of having people to detect these RFID tags and to manage it on a local software, the servers that need to be set up, the facility, the cooling facilities, etc. of these servers, and just to keep the infrastructure running for hosting people at site. It's just a big capital capex reduction that we offer. So with that, I kind of come to the end of my slides. Ashley, if you want to take it from here.
Yeah, thank you so much for that great presentation, Kush, on LoRaWAN and RFID. It's a fascinating solution, so I appreciate it. Looks like our subject experts have flagged a question for you from the audience. Let's see. Okay. What ROI data have you seen from past customers that are utilizing LoRaWAN and RFID solutions? Would you like to answer that?
Yep, sure. So I think that's a very relevant question, and at the end of the day, that's the most important question. One of our past use case was with a large conglomerate that was having about 17 warehouses in a 5-hectare land, and All these warehouses had different trucks passing through them, and the customer wanted to detect the latency, the amount of time that these vehicles take and waste. When they arrive ad hoc, people start shuffling around and like start gathering the material when the trucks arrive, and instead of that, we give them an estimated time of arrival based on RFID. So what we saw that the customer was able to cut down the time of arranging material in advance and knowing the estimated time of arrival. The real-time tracking itself gave us a 50% ROI. Instead of a 30-minute time gap, we were able to do this in less than 5 minutes by prepping up the team for the expected arrival of the truck and loading it in time. This was almost a 50% ROI that we saw for that one customer, and it definitely depends on case to a different case. It could be higher, it could be lower, but that's from one customer that we saw here in India.
Great. Thank you so much for that answer. All right. Thanks.
Thanks, Ashley.
All right. I'm going to move into interested in becoming a member of the LoRa Alliance. Thank you to the LoRa Alliance members who participated today. Please take a few moments to learn about the great benefits that are available to LoRa Alliance members by viewing the LoRa Alliance member brochure in the resources section. And we strongly encourage you to come and join the LoRaWAN ecosystem that these great member companies that presented today are a part of. Here are just a few of the reasons of how the LoRa Alliance and the membership can support you and your business. This is included in today's PowerPoint deck, available for download. So take a glance at this slide talking about expanding your LoRaWAN business and growing revenue, learning from the world's premier companies developing and using LoRaWAN, getting your voice out there in the ecosystem, boosting your brand, and getting extra regulatory support are just a few of those key benefits. And a final plug for the LoRaWAN World Expo happening next March in Paris. This event is open to the public, and we hope to see you there. It is going to be the LoRaWAN event of the year. So we're excited to see all of our fellow ecosystem members and hopefully many of you new audience members. Thank you again for joining today's webcast. It will be available on demand within 24 hours using the same link you used to join today. If you enjoyed today's topic, please share with your colleagues and networks and join us again soon for the next Destination LoRaWAN webinar. And with that, we are going to sign off. Have a great day, everyone.